So in this video I'm going to be talking about how atoms change into ions. Okay, so we've learned about, or we've talked or touched upon what an atom is. Okay, and I got the definition wrong last time, so we'll just reread that. An ion is a charged particle from an atom which became a charged particle as a result of a gain or loss of electrons. So it's basically the subatomic particle electron which causes it to turn from an atom to an ion. When it does, an atom can maybe have a stable or an unstable outer shell. An ion in IGCSE O levels, it has a stable outer shell. Okay, so it's like an atom wants, when it gains a stable outer shell, it has become an ion. Okay, some of them already have stable outer shells, so therefore they don't need to gain or lose electrons. So let's take two examples. Okay, let's say we have, this is the nucleus and outer shell, two outer shells, or two shells, energy levels, nucleus, two shells. Okay, and in this one you have, the first one can withstand 2 electrons only, the first shell, and the second and upcoming can take in 8. And this one has 5, 6. Okay, so let's differentiate between these two. Okay, now this one, okay, so you can see something similar. Their first, or their inner shell, is full, so it's this one, it's full, it cannot take in any more electrons. Okay, the outer shell, however, is unstable, so their outer shells are unstable. Now in there are two cases in both of them, and in each one they do a different one. So as we said, it's the first shell which takes in 2 electrons and the rest take in 8, so it can take in 8 electrons. Now the question is, what will it do? Now in order to gain 8 electrons, it can add 7 or take in 7 electrons, which will come into this energy level, or it can lose 1 electron, which is basically this one. When it loses this electron, this whole energy level is gone, and this one, this outer shell, this is now became the outer shell, has 2 electrons and it can't take in any more. Therefore we said that an atom takes the easier choice and it loses 1 electron. When it does, and as we said before, that the number of protons is equal to the number of neutrons. However, when it becomes an ion, there's a shift, so it's either the number of protons is greater than the number of electrons. I'm sorry, I wrote N, so electrons, or it's the number of electrons that is greater than the number of protons. So in this case, when it loses 1 electron, this electron is gone and this whole energy level is out, and therefore the number of protons and electrons has changed. There are 3 protons and 2 electrons. 3 protons means 3 positive charges, and 2 electrons means 2 negative charges, or negative charges. Now because there's an extra positive charge which is making it a charged particle, you write it with the element. So you write the element's name, not the name like the, like hydrogen stands for H, sodium stands for Na, so like, and then you add its charge, so it's over here, it's plus. Let's see this one over here. This one, as you see, it had, again, first shell is full, it's the outer shell that's unstable. Okay, so as you can see, this one has 6 electrons, and the second shell can take an 8. Yeah, so in order to become or have a stable outer shell, it can gain 2 electrons or lose its 6 electrons, which are here. Now we said it goes for the easier choice, so it loses 2 electrons. when it takes in two electrons. When it does takes in two electrons, when it does, there is then again there's a shift in the changes. Therefore this time the number of electrons is more than the protons, and when that happens, this means there are more negative charges than positive. And because there are the same number of protons and electrons in an atom, and two have gained, this means that there's two extra 2 minus charge. So we write the element's name or abbreviation or whatever you call it, and a 2 minus charge. Now let's get into like proper examples. Okay, we'll take two examples. Let's take magnesium, and let's take magnesium, and let's take fluorine. Let's take fluorine. Okay, so let's write fluorine here. Magnesium has 12 protons, therefore 12 electrons, and has 12 neutrons. Okay, so if you draw that, I'll not draw the nucleus because it's going to take a long time. I'll just draw the atom, or the electrons I mean. So it would look something like this. Okay. So the first two go in here. Okay, so therefore it becomes 10 electrons becomes 10. 8 more go in here because that's the amount this energy level can withstand. So 8 go in here, and I forgot to draw one more. So therefore we are left with 2 electrons, and those 2 electrons go in the last shell, which is the outer shell. Now if you see this and this, these shells are full. They can't take in any more electrons. It's the outer shell that is unstable, and it needs to become stable when it becomes an ion. So it can gain 6 electrons because this shell can take in 8 electrons, so it can gain 6 electrons, or it can lose 2 electrons. So it goes for the easier choice, the atom. Atoms don't have minds, it's just like my way. When they lose these 2 electrons, this whole energy level is gone, and this creates an imbalance. This time there are more protons than electrons, and due to that there are 2 more protons than electrons. So then we write magnesium with, since there are 2 more protons, so a +2 charge, so we write a 2, which is the number of extra protons, and whether it's the number extra protons or electrons. Now let's quickly do fluorine. Fluorine is 9 protons, 9 electrons, and I believe 10 neutrons. Okay, so now I'll draw the nucleus. And I'll draw the shells. So first shell takes in 2, so then we are left with 7 electrons. Oops, that's too big a circle. Okay, and then 7, the other 7 go in here. 4, 5, 6, 7. Now again you can see this shell is full, it can't take in any more electrons. It's this shell that needs to become stable. Now this shell can take in 8 electrons, this one can take in 2, that's why this one is full. So in this case it can gain 1 electron or lose 7 electrons. So it will gain 1 electron, so which is the easier choice. When it does, this therefore means there are more electrons than protons. How many more? 1. And therefore we'll write fluorine with the charge, which is -1 minus charge, an extra 1 minus charge, and we'll only write minus. We don't write 1 minus. That just it's not how we write it. Okay, and yeah, I'll just write so an extra electron. So I hope you guys enjoyed this video. Please do like, share, subscribe, and comment. Let's go. Let us go.